Parabolas are intersecting a cone with a plane such that the plane goes through the bottom of the cone, but doesn't touch the second cone, or else it becomes a parabola. And there's big differences between, or it becomes a hyperbola. It's a big difference between a parabola and a hyperbola. Obviously, the biggest one is the hyperbola. It's got two. There's like two curves that are back to back. But also the hyperbola is more V-shaped, whereas a parabola is more U-shaped. And both shapes are kind of similar, but we'll see when we get into the parabolas, the difference. But the next thing about where are you going? Gotta go down. Come on. There you go. Good job. The next thing I want to say about a parabola is this definition that you see here. And Ben was in person last week. And so, Ben, remember we were folding the paper? That was fun, right?
Yeah, good times.
Yeah, good times, folding the paper. So virtually we didn't have to fold paper because it'd be too hard to figure out. But what we were trying to figure out there was what shape was happening as we folded this paper in such a way. And the shape that occurs is the parabola. The parabola is the set of all points that are the same distance from a line and a point not on the line. So if you look at the picture in the bottom corner, bottom left corner, there is a dotted line called a directrix. Up above the directrix, there is a point called the focus. Okay, so every parabola has a directrix and has a focus. And those are two parts of a parabola that you've never mentioned before, right? You've never said the word directrix, probably. So when you graph parabolas in Algebra 2, you were putting parabolas all over the place. And, you'd move them left and right. You'd flip them over and make them a sad face parabola. But you always would use the word vertex. Where's the vertex? Find the vertex. And there was a way to get the vertex. But it turns out that there is also a point above the vertex, if the parabola opens up, called the focus. Below the directrix, below the vertex, there's a line called the directrix. Every point, if you read back to the definition of the parabola, every point on the parabola, every point is equidistant from the focus and the directrix. So you see the D2 that's listed in the graph. The point on the parabola is equidistant from the focus. The distance there is D2. And then it's also the same distance from the parabola to the directrix. So D2 is the same as D2. D1 is the same as D1. And the distance between the focus and the vertex is the same as the distance between the vertex and the directrix. I guess maybe you could see my cursor. I don't know if it shows up on the video or not. Yes, it would, right? So from the directrix to the focus, there's a distance here. From the directrix to the vertex, from the vertex to the focus, and from the vertex to the directrix is the same distance. That distance we denote by the letter P. P as in Patel, right? Or Peter was my grandfather's name. Paul is one of my good friends. So P. If you look in the bottom of the screen here, we get the standard form of a parabola. And this would be the conic form, I guess. You'll notice the equation has an x minus h squared and a 4p and y minus k. So the parabola, like a circle, it has an h and a k. Now the h and the k for the circle, remember, was the center of the circle. The h and the k here is the vertex of the parabola. So at first this is going to seem a bit weird because we're looking at formulas. We're not looking at an example. So I'm going to get to an example real quick. We'll switch to the notes in a second. But this is the formula for the standard form of a parabola. And when I say this, I actually mean these. There are two of them. Because what can happen now that is sort of different from Algebra 2 is your parabola could not open left or not open up or open down, but it could open left or right. So as I scroll up, there's some pictures at the bottom, and I may zoom out. I can try to see the equations and the pictures at the same time. There we go. This is all page 438 in your book. Looking at the graphs at the bottom for a second, okay? Notice the very far left graph, the parabola opens up. That's like a good old-fashioned x squared that we're used to from like almost every day of Algebra 2, right? Parabolas, parabolas, parabolas were like months of Algebra 2. Well, at least a 1 month of Algebra 2. If your parabola has a negative in front of it, right? If it's negative x squared, the parabola opens down. So those two things on the left, those two graphs on the left should be sort of familiar to you. And remember, there is a directrix and there is a focus. Every parabola has a directrix and a focus. We just never talked about them before, right? Well, what could happen is if y is squared, your parabola opens sideways. This is what I call a sleepyhead parabola. Because like, you know, when the parabola opens up, it's like you're smiling, right? An upward parabola is like happy face. If it's a negative x squared, the parabola opens down, so it's like sad parabola, right? Frowny face parabola. But if it's a y squared parabola, the parabola's on its side, which is like when you're sleeping, you know, you're like your head below and you're like laying on your side. So a sleepyhead parabola is the one that opens left or right. And just like when it opens up, x is positive. If a parabola opens to the right, y is positive. If the parabola opens to the left, y is negative. So up is positive, right is positive. Down is negative, left is negative. Sorry for all you lefties out there like me. But notice the parabola has a directrix and a focus every time. It says up here in the notes that the vertical axis is what happens when you have x squared. Well, that's that axis they're talking about there. The vertical axis is the axis of symmetry. So the axis of symmetry will be vertical when x is squared. If the y is squared, the axis of symmetry becomes horizontal. So look at these two equations right here, what really matters. X minus h quantity squared equals 4p times y minus k. So what you've got to do for a lot of problems is put them in this form. So the first example that I have, boom, is y equals x squared. So at this point, can somebody unmute? Do you see the notes with my gorgeous handwriting?
Yes.
Yes. Okay, so we switched from book to notes. So we can actually do some math now, and this is going to go faster, and we'll get this thing over with. So look at y equals x squared. That is the most basic parabola. Maybe in Algebra 2, your teacher used the word parent function, depending on who your teacher is. This is the parent function for a parabola. This is the basic parabola. And you can graph this thing very easily, you know, from like your brain because you're smart. Like, what is 0 times 0? Well, 0 times 0 is 0. What is 1 times 1? 1 times 1 is 1. What is 2 times 2? 2 times 2 is 4. What if it's negative 1? Well, when you square a negative, it's still positive. What is negative 2? When you square a negative, it's still positive. So there's the graph of the parabola. And I totally missed that point over there, lefties. But, and it could be a little better if I was using graph paper. Like that was Algebra 2. What's the vertex? Oh, you see the vertex right here. It's 0, 0. Well, what we're doing here in pre-cal is analyzing like the conic section properties of a parabola, which gets into talking about the directrix and the focus. Those are what two of the things they ask you for every question is, what is the directrix? What is the focus? What is the vertex? And then what is a sketch of the graph? So you see right now, I've made the graph already. Normally I kind of do that as I go along, but what I really am going to have to do first is I need to put this parabola right here in the conic form. Okay. Now, what was the conic form? This is what we saw on the other page. And maybe you wrote it down already, but maybe not. The conic form is a little backwards because with the conic form, the x squared comes first. The x squared is on the left side of the equals. What is on the right side? The right side has a 4p, okay, and a y minus k. So this is our form of the parabola, right? The conic form of a parabola. And because like there's different forms, like you may remember from Algebra 2, there was a vertex form of a parabola, there was a standard form of a parabola, or quadratic. There was even, maybe you went into the intercept form. I don't know if that ever got used or not, but I'm calling this the conic form. Is I want to get this pattern out of this equation. So what would I have to do first? The first thing is I'm going to take the blue equation and put x squared on the left, y on the right. Okay, that's the first step. X squared's on the left, y is on the right. Now I want to try to figure out what is my h, what is my 4p, and what is my k. Well, you're going to use the numbers that are there. Like, for example, x squared is actually x minus, what number is actually there for h? There is a number for h. Since I'm not subtracting anything, it has to be what?
0.
0, right? There's a 0 in there. And the same would be true for y, right? This is y, in parentheses, minus k. Well, there is no k. If there were a k, it would already be there, right? It'd be like y minus 2 or something. But there is no y minus 2. It's just y. So what number does k have to be?
0.
0. Same thing. Fun stuff, right? This is a blast. We were having so much fun. So sometimes when you don't see a number, it's a 0. Sometimes when you don't see a number, it's different. Like, remember when we did logs? Like log without a base meant there's a 10 there, you know? Like this was log base 10. If you don't see a number, it's a 10. If you have a square root, right? Oh, come on. What is the square root of 4? Well, how do I know that's square root? I didn't write what type of index it was. I didn't write the type of root. So if you don't write a number, we assume to be a 2. So sometimes when you don't see a number, it's a 2. Sometimes when you don't see a number, it's a 10. Sometimes when you don't see a number, it's a 0. It can be very confusing, you know? But what number is in front of y? In front of y, right here, you don't see a number. But there is a number in front of y, because how many y's are there?
1.
1. So what I just did was I took the simple y equals x squared, the basic equation, and I turned it around and made it into the conic form. This is the conic form, and notice it matches what you see, you know, up here. Supposed to be the highlighter. See, this thing matches this thing. So now I can figure out my HK. What is my HK? Well, my HK is the vertex. The vertex is HK. And what is the vertex here? Well, 0, 0. And I know you're going, bruh, bruh. Everybody go, bruh.
No, thank you.
Okay, so the 0, 0, we already knew that over here. Like, bro, we already knew it was 0, 0 like an hour ago. Why are you wasting my time? Right? This kind of looks like a little face to me. Okay, sorry. Not as good at being Bob Ross as Bob Ross is as good at being Bob Ross. What else you got? Well, it turns out there is a focus and there's a directrix. How do you get the focus and the directrix? You first have to find the number p. And you see I had written on the bottom right corner, like p is the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. But I didn't want to rewrite that, so those notes have been there for actually a couple of years. I use the same like file year after year, and I just erased the problem, and then, but I've always left those notes. So how do we get this number p? This is like what we have to figure out for most of these problems. Well, go back up to your formula. Remember the 4p that you see here will equal the coefficient of the y. So 4p is 1. 4p is the number 1. That number 1 is actually kind of a big deal for something that's going to come up in a minute. But for the most part right now, we're just going to set 4p is equal to 1. And now what would p equal? What do you do to solve for p? How do you get rid of timesing by 4?
Divide by it.
Divide by it. So p is 1/4. So p is the distance from the vertex to the focus. And this is why I don't normally do the graph first. I'm going to leave that graph there, but I'm going to scratch it out. What I normally do is I do this, the vertex, because I know that's 0, 0. Now I'm going to go up. To see my notice P is positive, right? P is a positive 1/4. If P is positive, the parabola is going to open up if X is squared. If P is positive and Y is squared, the parabola will open to the right. Okay, so our next example is going to be a Y squared problem, right? If P is negative and X is squared, it'll open down. So because P is a positive 1/4, I'm going to go up 1/4 above the vertex. This is my 1/4. That point right there is my focus, the purple dot. And so now what is the coordinates? What are the coordinates for the focus? How would you figure that out? If the vertex is 0, 0, and I go up 1/4, what are the coordinates of the focus? Well, if you go up, does that change the X value?
No.
Nope. It only changes the Y value. So the Y value is different. The X value is still 0. And the Y value is going to be what number? Am I going up?
1/4.
1/4. So the focus, if you go back and we go look at the book, is 0, 1/4. They give a bunch of like sort of, where's the book? Here it is. They get a bunch of numbers down here that I find could be sort of confusing, right? I would rather you not try to memorize what you see here, but just understand what's happening. Notice it tells you the focus when P is positive. See, vertical axis, P is greater than 0. It's X squared because that's how you have a vertical axis, because it's X squared. P is greater than 0, which means the focus is above. So how do you get the focus? It's H comma K plus P. Notice the H coordinate from the vertex stayed the same. The X coordinate stayed the same. The focus is K plus P, which is, it's easy to understand that. But I find like that some students could maybe get confused, because if you look over like at the next one, it's like H comma K plus P again. If you look over here, oh, look, now it's H plus P comma K. So I don't want you to think, oh, is it minus or plus or minus? It's just, if I'm going above the vertex, I'm going to add the Y coordinate. If I go below, I would do the Y coordinate minus P. And P is negative, so it's the same thing. So there's my focus. The directrix is below the vertex. And it's below the vertex the same distance. It's 1/4 below the vertex. You have the directrix. And if you remember those graphs, the directrix was always drawn as a dashed line. It's drawn as a dashed line because technically it's not a part of the curve, right? It's not a part of the parabola. But it's like, it's connected to a parabola. It's like, it's useful in finding a parabola, but it's not a part of the graph. So if you draw it as a solid line, then it's like you're saying the parabola is a curve, the U-shaped curve and a line. So it's not. So it's just kind of technicalities. If you made it as a line, I wouldn't count it wrong. But what is the equation of the directrix? That's something else to ask, is how do I get the directrix? Well, notice in this case, it's a horizontal line. And a horizontal line is y equals, right? Negative 1/4. I kind of have no idea where we are. What time does this class ends at 10, I think, right? It started at 9:20. Okay, yeah, I just remembered. So there's basically our directrix and focus and vertex. Now, how do you make the parabola? Well, you might go, well, you just easily just make it a U shape, There's something else that we can do to make the parabola using this number P. Because remember, the distance between, pick a color that's not up here. Let's use orange. The distance between the vertex and the focus is the same as the distance between the directrix and the vertex. Those two orange lines are the same distance, okay? So what that would mean is, and so what is P plus P? Anybody got that one? P plus P. would be a half because it's a quarter plus a quarter, right? So if I were to step 1/2 this way, 1/2 this way would be the same as 1/2 this way. That 1/2, remember, was p plus p, or 2p, right? So if I go from the focus, if you go from the focus directly left or right, so we're talking parallel to the directrix, right? If you step over 1/2 straight to the right across, that point will be on the parabola because it's 1/2 from that point back down to the directrix. Notice I've got like an orange square here. At least it's supposed to be a square. And this is our definition of a parabola. The parabola is the set of all points equidistant from a line and a point not on a line. A parabola is the set of all points equidistant from a directrix and a focus. So this pink line that I'm drawing in here and this pink line, they are the same length, okay? Just like the orange line was the same length, right? So the green dot that's in between these two orange dots, this green dot here, right? Notice it's equidistant from the focus and the directrix. And then this green dot that's over here, that's connected to the pink lines, that green dot is equidistant from the focus and it's equidistant from the directrix. So you can easily get points on a parabola. I'm going to undo all these little chicken scratches. Because right now I'm going back to here. All I know really is my vertex. How do I get other green dots? If I go over 2p, that will be a point on the parabola. Boom, and there's half my parabola. Just graph it like that. If I go over 2p the other way, right? 2p or not 2p, that's a point on my parabola. This distance is 2p. This distance is 2p. And what is 2p plus 2p? If I add, not the numbers, but the letters, what's 2p plus 2p?
4p.
4p. And remember, you're told in the very beginning what 4p equals. So this 4p number, the number 1, in this case, the number 1 is a way to graph the parabola actually very quickly. You go a half of 1, which is a half, right? You go a half of 1 to the right and a half of 1 to the left, and you will have 2 points on your parabola. What's nice about this is that means you don't have to calculate actual values. Like, I'm not going to plug a number in for x and do a bunch of math and get a number out for y. I don't have to do any calculation. I just go over 2p and over 2p and put the dots. Now, you might be thinking, Cork, it's not a big deal to do the calculations here. This is an easy equation. And if you look back at the top, this was an easy equation, y equals x squared. Okay? But the equations are going to get messier. Right? The equations will get yuckier. And also, so this 2p plus 2p, which makes 4p, is an easy way to make a graph. It really is, when you get what's going on. I'm going to do another example here real quick because I know we got to go. But something else that I need to say that's kind of fun is I'm going to erase my 2p's. This line here, the line that goes from 2 points on the parabola through the focus, that line is called a focal chord, okay? There are lots of focal chords. Like, every single one of these lines is a focal chord, okay? As long as you have a line segment that goes through your parabola and it touches both ends, and it goes through the focus, that's called a focal chord. Well, the one focal chord that is parallel to the directrix, which has a length of 4p, right? That focal chord is called the lattice rectum. And that is something really weird and crazy, and you will never hear again in your life. And it doesn't really relate to much of anything other than the fact that saying lattice rectum is kind of funny. You know, it's just like, why? I Googled this up on Monday in class, and lattice is Latin for side, and rectum is Latin for straight. So this is what is, I guess, considered the straight side of a parabola. This chord right here, this line segment, is the straight side. Why does that matter? I don't know. It doesn't, but it's just kind of crazy to say lattice rectum, you know? So like tonight at dinner, when your parents are like, how was your day? You can be like, we talked about lattice rectum. And they'll never ask you again. You know, they'll be like, never mind. I don't want to know, you know? So this is a thing. I didn't make it up. It's in the book. I was like, that's crazy. When I was in high school, I don't remember my teacher ever talking about lattice rectum. It might've been because I was in high school, so I wasn't paying attention. You know how you guys aren't really paying attention right now? But it's sort of my duty to remind you of all these things. Lattice rectum is that linked. Okay, cool. One more example. We got to go, Mr. Quirk. We have less than however much time we have. Where's the other example? It's down at the bottom. Oh, shoot. And I didn't erase it. Well, how about we don't erase it? I'll just leave it here like this. I won't erase it. So notice on example 2. Example 2. How does this problem start out? It starts out like this. Ignore all of this. None of this is here. Here's your equation, okay? 4 times the quantity x plus 5 is equal to y minus 1 quantity squared equals 0. So what's happening now, you'll notice, is the parabola is y squared. That will mean we have a sideways parabola, okay? So what I'm going to do first is put the parabola in this form, okay? I want the y squared to be on the left side. I want everything else to go to the right side. So this is form of a parabola. This is our conic form right here. So what would you do to get the 4 to the left, to the right side? How do you move a positive 4 times the quantity x minus 5 to the right side? Is you subtract it. So notice I get minus 4 times x plus 5, and the y minus 1 squared is all by itself now. So what is the vertex? The vertex still comes from H, which is over here, right? K. 4P. So the vertex is -5, +1. H would be -5, K would be +1. What do I do now? I find my focus. So maybe I should go over here and just fix the graph a little bit so we can talk about how to make the graph. The first thing I did was I put the red dot. The red dot is the vertex. The red dot is at -5, 1. Now, my parabola is going to open to the left. How do I know that? Well, I know that because down here in green, the focus, remember, comes from 4p equals -4. See that right there? The 4p coefficient is -4, which means p is -1. If p is -1, that means that my focus is 1 unit to the left of the vertex. Since y is squared, the parabola opens left-right. Since p is negative, I go to the left. So I go backwards to -6. So what is my focus? The focus is -6, 1. What is my directrix? The directrix is p units to the right of the vertex. And p units to the right would mean 1 unit to the right. So the directrix is vertical. And from algebra 2, you should remember, or even algebra 1, a vertical line is x equals -4. Like x equals a numbers of vertical line. So now how do I make my graph? How do I sketch it? Well, remember this 4p thing? 4p is 4. Now I know it's -4, but the lattice rectum is always a positive number, right? It's like the absolute value of the thing. So what is a half of 4? I'll ask you this question before we leave. Last question of the day. Half of 4 is?
2.
So I go up from my focus. I go up 2, and I go down from the focus. I go down 2, right? So I go from the focus, which is at 1, I go up 2, which is 3, and I go down 2, which is -1. So those 2 red dots give me my parabola. And notice I didn't have to calculate any numbers. So now go back up to the equation at the top. If I were to ask you, what does y equal when x is -6? Well, you'd have to plug -6 in for x. You'd have to do a bunch of math, right? -6 plus 5 is -1. -1 times 4 is -4. You would then add 4 to the other side. So y minus 1 quantity squared would equal 4. Then you take the square root of both sides. So y minus 1 would equal ±2, right? Y minus 1 squared equals 4. when you square root both sides, you get y minus 1 equals plus or minus 2. See, this is more work. Now, what does y equal? Well, y would be 2 plus 1 is 3, or negative 2 plus 1 is negative 1, which are the same numbers I had over there, just by counting up the lattice rectum, right? So I don't have to calculate any numbers if I just understand. I go from the focus, 2p up from the focus, or 2p down from the focus, or 2p left and 2p right. At this point, you guys might be thinking, Mr. Quirk, I have 2p, and class should have been over a minute ago, and we have to go to third period. So at this point, I need to let you go, okay? Maybe you've already left already. So I hope you have a good day. I'll see you later. Bye.